Very good evening to one and all. Am I audible to you? Atu sir,
Yes,
am I
ma'am.
audible?
Yes, ma'am.
Thank you, sir. Thank you so much, sir. So a very warm welcome and a pleasant evening to everyone present here. So welcome to the fifth day of Faculty Development Program on Inner Transformation for Outer Excellence in Skill and Teaching. That is organized by Khalsa College of Engineering and Technology, Amritsar, in collaboration with the Khalsa University, Amritsar. So as we continue this enriching journey of learning and self-development, today's session focuses on from inner awareness to innovation, transforming engineering teaching in the age of smart technologies. In an era that is driven by rapid technological advancement, it becomes essential for educators and mentors not only to adapt to innovation but also to cultivate the awareness, creativity, and we can say the purpose-driven teaching. So today we are privileged to have with us an accomplished researcher, innovator, and an academic leader whose work beautifully connects technology, research, and societal impact. So it is my proud privilege to introduce our esteemed resource person, Dr. Shravanti Joshi, Associate Professor and Associate Dean at R&D at Marathwada Mitra Mandal College of Engineering, Pune. Dr. Joshi is a highly accomplished researcher in the field of sensor technology, nanomaterial engineering, and environmental remediation. Since 2011, she has been contributing remarkably to research and innovation with exceptional dedication and impact. She currently leads the environmental remediation engineering laboratory and has an impressive academic profile that includes 13 high impact research publications, 10 book chapters, 7 patents, 6 funded projects, and more than 20 national and international awards. Dr. Joshi has proudly represented India at prestigious international platforms including G20, BRICS, and the Shanghai Cooperation Organization in thematic area of environmental science. Recently, she was also part of Young Leaders STEM category delegation invited by the Ministry of Science and Technology, Government of India. She has earned her PhD in sensor technology from RMIT University, Australia, where her doctoral thesis was recognized among the top 5% HDR performers also. She also holds a master degree in nanotechnology from National Institute of Technology, Karnataka, Surathkal. And ma'am, we are truly honored to have you with us today. And I now humbly invite Dr. Shravanti Joshi to kindly address the participants and share her valuable insights. Ma'am, please, it's over to you.
Thank you so much for your kind words. I hope I'm audible.
Yeah, ma'am, sure. You are
So let
definitely
me
audible.
just share my screen. So I would like to know if the slides are visible.
Yes, ma'am. The slides are okay. Visible to everyone.
Okay, thank you so much, sir. So good evening, all. Thank you very much for joining today's session. I'm especially grateful to all of you because I know it's a big task to do a job whole day and then come again and join FDP and go through a newer series of learning. But they say like joy of learning never ends. So I'll just start with the session that whatever I'll be presenting today, it's more of a discussion what I have been doing in my lab and how my students have turned out. So when I received this call from Dr. Kallurkar sir, regarding that this FDP is being conducted by Khalsa College of Engineering and Technology as in collaboration with Khalsa University. And he asked me if you can share few of your case studies, what is actually happening in lab and how things are being done in engineering college and how students are coming up with research, innovation, taking that step forward and how they are integrating that modern technologies along with IKS principles. So throughout the session, I'll be focusing on So throughout the session, I'll be focusing more from engineering point of view. Um, how things are being done. When I started, I saw myself as a mechanical engineer, and then I turned towards material science, and now I'm working in biochemistry. So it has been a huge change for me as well, for my students also, because these days they are also moving apart from that core theme of mechanical engineering. They are trying to do more innovative activities, which we call as multidisciplinary, interdisciplinary. So, throughout the session, I'll be focusing on what kind of awareness we need to have in our students and how IKS can help us. I think these days UHV is also trending up, that is universal human values. So, I won't be discussing that part, and then few of micro teaching models that I particularly implement in my lab, as well as smart technologies that we try to use in our research work. Along with that, I'll try to share few case studies from my own students. So luckily I have been blessed with really good students who have made me proud at various stages, followed by some acknowledgement. So I'll just share brief about me in case if anyone is interested in collaborating with my lab. So we do have expertise in sensors, particularly solid state sensors, gas sensors. Then these days we are also working on developing breathalyzers which can help in detecting tuberculosis, many infectious diseases in animals and so on. We also work in the areas of catalytic sensors. Also, we are trying to develop materials that can convert carbon dioxide into solar fuels like hydrogen, methane, methanol. And much of our lab focuses on sensor development, prototyping, and fabrications. So we have been lucky, the lab has been lucky to receive a huge amount of funding from Department of Science and Technology, World Bank through BIRAT. We have also received funds from GIZ, that is German government, and so on. So these are few things. Again, few of the students, they have really made me proud. So I'll be sharing few of their case studies today as well. Hopefully, it will motivate you as well as your students. So we do collaborate with many academic institutes in India as well as overseas. Also, we have good tie-ups and MOUs with many industries that do help us in technology transfer, prototyping, device fabrication, and so on. So let us begin. So I've been going through this few sessions from day one, and it started out really good with many good speakers enlightening us with their thoughts about inner transformation and how that excellence can be achieved in teaching as well as in research and many other areas. But if you ask me, since I have been leading three labs uh, during my 8 years of engineering career, so if you see, um, engineering teaching is you start with something, and by the end of that final year, the student is having some different perspective. So if you see, he or she will have different perspective. Even you get to learn many things from that student. So it is some kind of a multifaceted transformation. That is, he's learning 15 to 20 newer things. Maybe you are also learning 20 to 25 newer things. So these days, when I ask many students that if there are many courses in engineering, so if you are liking this kind of course, for example, it is related to materials engineering or it is related to production engineering, so why do you feel that course is good? Is it because the teacher is good, or you're getting some good kind of tech, you're learning about new kind of technology, or you are doing something which you have not done previously, or is it something that is taking you closer to your dreams? So even that thought keeps us awake many a times, that what makes a engineering teacher great or popular or famous among the students. So there are four options listed over here. Can few of me tell me that which part do you think is more important? Knowledge, technology, experience, or mindset? So please try to interact. I think it will be very learning experience for all of us. So I couldn't post a poll over here, but if it was a poll, what do you feel that which is most important part of being an engineer teacher? That he or she should have good knowledge, profound knowledge, or he should be aware of technology, or there should be a vast experience associated, or there should be a very different kind of mindset. So please, I request you all to answer.
I think knowledge is very much important. And secondly, we have a positive mindset to apply that knowledge. And then we need a good experience, and then we can understand the importance of the technology.
Thank you so much, sir. So, yes, very true. Anyone would like to add anything over here?
I feel, ma'am, I feel that the knowledge is very important, and keeping your knowledge updated is very important in today's world, because the students are very aware of what's happening, especially in engineering or in the technological field. I feel that they are pretty aware of the things that are happening, and they are very curious about it also, to know more about it. So it's very important that we keep ourselves updated, and you upskill ourselves from we upskills ourselves from time to time.
Thank you so much, ma'am, for that insightful answer. Anyone else? So good thing about such kind of FDP is that you get to interact a lot. You get to know what other teachers are feeling, what other faculties have on their mind. So it's a great experience, and I would want all of you to at least interact.
Ma'am, faculty members are interacting via chat also.
Okay, okay. So I'm unable to see that. Okay, so sorry for that. Sorry for the inconvenience. So I think yeah, whatever answer I have received, that knowledge is very important. But do you feel that knowledge is enough when we talk about teaching or modern education? Yes, knowledge is very important. So maybe it is like 80 to 95% knowledge is important. But even other things other than listed over here, other than technology, experience, or mindset, even other than that, that connect is important, or having that a different kind of you say EQ is also important. So many things are there, and we as a teacher, it is a continuous learning path for us. You know, till the end of the day we resign, we still try to figure out what can be done that will make a student improve his academic score, or that will strengthen his CV, or how I should be helping that student so that he's the one step ahead of others. So if you see, so many things are there, but I'll be just focusing today on what is happening in my lab. So I request the organizing committee to share with me if some thoughts are being shared in chat box, because I'm unable to go back and forth with this presentation.
Kindly repeat, ma'am, what you have said.
So I request the organizing committee, if someone is putting any comment on the chat box, so please stop me and let me know that.
Right.
Okay, okay, sir. Thank you. So moving forward, if we talk about transformational teaching, a great impact is again put forth by the environment. How open is the college? How open mindset is being there? Or what kind of rules are being implemented? What kind of innovation, incubation strategies are being supported? If the pedagogy is relevant with the modern times, if there is some sort of outreach activities that are taking place in terms of, maybe there is support to student for preparation of competitive exams, or maybe some competition, or if they want help with the preparation of paper presentation, oral competition, or if they just want to do new learn new software or do something innovative, that will not fetch them any kinds of marks. They just want to grow themselves through this software or maybe some other kind of learning activity. So if you see, there are many steps when that student is coming in the first year and through the final year. So maybe there is some sort of information absorption, then he's trying to learn something, maybe he's trying, when he or she goes to some other college or participating in some other activities, they try to learn something, maybe there is some impression that is being forged on their minds. Okay, if they are going to some other college in other state, they are observing some cultural difference, maybe that is what is enlightening them, or maybe some exchange of knowledge. So most of the time, when students they participate in exchange program, even there also they do try to learn newer things that they can bring back to the institute as well as the society. So if you see, even for students, the learning never stops, as well as for us as a teachers and faculties, it doesn't stop till the very end of the day. So my basic thing here is that education should not stop only at gaining some information or some knowledge. Okay, so it must be something that can be absorbed by us, and it can be translated and as well as implemented by the student. So if you see, a lot of things they are there when you try to go through that learning journey. So many a times, so let me share one good example with you all. In my previous institute, so it's a one of the engineering and technology institute. So one student, he got admission through management quota, and he was like, okay, I have to get this thing through because my father is a manager at this big company, and somehow he can pay management fees, and I'll just go through this 4 years of engineering, and then maybe I'll go to US, get some job, come back and join his company or have some startup. So initially, when he started out with this casual attitude, and after first semester, results were declared. So he got a CGPA of, I think I do remember, 4.7. And his father was really shocked and surprised that even after investing so much of money in this guy, and he has still responded this way in exams, and nothing is going to good happen. So he came to our director and he was discussing. And luckily, I was there because I needed some signatures on the document, and I happened to overheard the entire scenario. So it was like his father was completely shattered with this kind of CGPA. And he was telling the director that the elder son is so good that he has never received a CGPA less than 9, and then there is this fellow who is not going above 5 CGPA. And I have happened to invest all the savings which I thought I'll be using for the elder one, since he had not asked anything because he will be getting scholarship all the time. So I feel that this is completely waste of time. And then our director was like, no, no, these things happen. And it is just first year. So you give him time. And by the end of second semester result, again, his score was 4.3. So luckily they were like, okay, with this kind of thing, let him give re-exam, and maybe once he gets 6 CGPA, he can be sent to second year. And then he came to second year, and I happened to teach him metallurgy. So I observed him, he was very much quiet, and he was not interested in any of the teaching activity, nor he was interested in doing any kind of lab work. So he used to just sit. He was not creating any trouble, he was not creating any menace. He was writing his experiment, submitting on time, he was punctual. So you cannot point out any problem in that student. And then I happened to give them few assignments based on unit, and they had to submit 6 assignment based on 6 units. And I told all of them, okay, since this is a COVID period, and you should be emailing me. And to my horror, all the students, they neither wrote the subject line nor anything was mentioned in the body of the email. Everything was just attached and sent. So the documents were not numbered. There was no roll number. There was no name. And I had this tough time in sorting out which assignment belonged to which student. And then one fine day at 3 a.m. in the morning, I saw my emails, and there was this email from one student, cleanly titled subject line, assignment, metallurgy subject assignment number 1. And he had clearly mentioned, dear ma'am, as mentioned by you, tomorrow is deadline, so I am submitting my assignment. Thanks and regards, so and so. So I won't reveal his name. Let suspense continue. I'll let you know what happens to this student. So I was shocked. Out of 135 student, one of this guy who has clearly written very good email, who has attached the file, he has written his name, he has written his roll number, and he has sent it to me. And next day he was very quiet. He didn't expect anything, nor I mentioned him anything. And then at that time, recruitment for project associates in my lab started. So it is my principle that I usually take 4 students every semester from second year, so that they train in my lab, do some research, and they try to take some additional skills. And that year, I think none of the students cleared the recruitment. And I was shocked. Okay, I have no students who will work in this lab. What will happen? So I happened to remember this fellow, and I called him that, are you interested in working with me? This is kind of things we do. And would you like to be part of it? So he was like, okay, I'll just inform you in 2 days. I said, why 2 days? So he said, I need to ask my parents. I cannot just come to your lab and start working. I need to understand what are the safety precautions. So I said, okay, fine. So exactly after 2 days, he came to me and he said, okay, I can work in your lab, provided that I'm given off on Sunday, because that is my me time and I don't want you to interrupt with my me time. So I said, okay, fine. Then I was curious why he took 2 days and he came back. And then I asked him what your parents said. So he said, my father just said, do whatever you want, don't create trouble for me or your mother, and do whatever you want. Then Initially they were like, don't go to this lab, you need not do anything because hardly you're getting good CGPA, so why bother to do some research which requires good knowledge and good CGPA. So then he told me again, he stopped and he told me that, okay, I told my brother who is in Tesla, USA. So he requested my father that allow him to go to this lab and let him do some work. It will strengthen his CV. And then my father agreed. And that's how I came back. And then he started working in my lab. So I'll continue with this story in some time, what happens to this student. So please stay with me to know what is the climax of this student's movie. ओके सो इसके साथ बाद में क्या होता है ये बड़ी दिलचस्प चीज है। तो मैं सबसे गुजारिश करना चाहूंगी कि आप ये मेरे साथ रहिए, because you will be surprised to hear what actually happens to this student. So moving on with my slides. So if you see as a teacher, since the implementation of NEP, we have been facing a lot of challenge in terms of modern education. There is always this comparison with the traditional knowledge versus modern teaching, whether the teacher centric or student centric. So if you see the current syllabus or current scenario in academia, it is a lot of comparison is happening because there is lot of information with the teacher, but student is not able to receive it. So what is happening? There is a lot of knowledge, there is lot of wisdom, but somehow it is not being translated. It is not reaching to student. Even if it is reaching to student, maybe they are not able to use it properly. They are having some other ideas. We are having some other ideas, and somehow we have to come to a common path. So many a times, if you see the classroom, even I think you all must be experiencing that few students are really good. They don't need any supervision. They are able to do their things. They are able to get things done. But some students are very slow. You have to motivate them. You have to mobilize them. So a lot of time goes into that. And if you see every semester, every day, you have to have that brainstorming with yourself that how this student can move forward. Okay, so again lot of gaps are there, no doubt. The curriculum or syllabus, we are updating it in terms of smart technology, maybe AI is being implemented. So last 5 to 10 years, even AI is coming into picture for mechanical engineers as well. Initially it was only restricted to soft branches, but these days it is in mechanical, even in biotechnology, in civil, and so on. Though there are gaps, we as a faculty, we are trying to connect the dots by including industry based co-teaching. Then we are having those internships. I think many of the institutes, they are encouraging short-term industrial training programs for faculties. Then there are again FDPs that are being conducted on regular basis, that are also being given good marks in appraisal. So many things are happening. So if you see, if you connect the dot in today's FDP, so inner awareness to outer excellence, it is particularly what teacher is thinking and how students are reacting to it in terms of skill development or skilling programs. So if you see, we can connect those kind of dots, that whatever teacher is being providing or implementing, it has to go through a student. And that is how the outer excellence is being valued in terms of many things. Okay, so if you see a lot of times, gone are the days when it was focused as teacher centric learning, where teacher used to come, write something on blackboard with chalk and some diagrams explanation, and student used to go maybe read, understand, come back, and try to implement some part of it. But these days, due to NEP, and many other activities by AICT, DT, even Education Ministry. So more focused is on student-centric learning in terms of hackathons. Lot of gameathons are there, idea evaluation competitions are there. If even if you go to a particular conference, you can see student population is huge in terms of undergraduates, postgraduates. Even many students are competing right from school days in terms of competitions, startups. So I think in Pune, two, three schools are there who are encouraging startups. So you see fifth standard, even eighth standard students coming up with startup ideas, and students are getting funding for that to implement their ideas, not in terms of thousands, but they are getting grants in terms of lakhs, sometimes even in crores in overseas universities. So, if you see, there is a comparison of traditional lecture versus active learning. The growth curve is always increasing. Unlike the traditional teaching, where the learning slowly decreases right from first year, if you see in terms of traditional teaching, students they get bored over a period of time, and by the final year they don't turn up in the colleges. But that is not happening in today's era. So, if you see in terms of outer excellence, I think these days more importance is being given for Indian knowledge systems. They are acting as foundational concepts, even universal human values. So, not only for students, even for faculties as a teachers, transformation is very huge. So I do remember when I was doing my BTech. So that time teaching was a very mundane job. But these days it is very exciting. You get to play many roles as a teacher. So you are a teacher guardian, you are a research mentor, you are there some sort of hackathon mentor. So many things are happening for teachers, and it is this continuous update, reskilling, skilling with teachers that is taking place is also helping students to gain that a step forward in their academic career. So, in addition to being a good teacher through this student-centric learning options, one thing is there that though we have this modern education, we have also increased document part. So I don't know, but once I visited one of the institute in Mumbai, and I was shocked to hear that they are taking students' attendance in 4 to 5 ways. So they are taking sign on hard copy, they are scanning it, they are generating data through ERP. Again, they are filling that data through Excel. So I know many a time students, when they come, even if they are missing 1 or 2 lectures, they go and complain to faculty, no, no, I was present, but you have marked me absent. So in this scenario, documentation is important. But I feel that with newer technologies, I think reduced documentation is also a big thing, change coming up. So another thing is, so this thought I get many a times when I'm talking about teacher-centered and student-centered learning, that is traditional teaching versus modern education. So many a times I do get this thought that why did I become a teacher, or whatever I'm teaching or discussing in my class. So does it help student, or is it even impacting him or her? So I would like to know answers from you all regarding these two thoughts, that why did you choose to become a teacher? Or do you pause sometime like me and reflect on what you're teaching? So all are requested to write their answers in chat box. So I'll be happy to read your question answers. So if anyone is interested, they can share their thoughts also. So anyone would like to share their thoughts that why did you become teacher, or uh, do you ever feel that whatever you are teaching is impacting the student? No one? Okay. So maybe if you get time and opportunity, maybe you can post your answers in the chat box about your motivation for becoming a teacher, particularly in this era where everyone wants to join IT or do some other job such as content creation or something like that. So while I move on with my slides, so one thing is there that if you compare teacher-centered versus student-centric teaching, so a huge gap was observed, and hopefully that gap has narrowed down. So initially, when I think I remember when my teacher used to talk and talk during the lecture, and we would just listen. And those days, even mobile phones were not there. But these days, in my class, I think we as a teachers, we do give some points for them to prepare slides, and maybe they can come to class prepared, and maybe they can take one or two topics for discussion, so that it happens peer to peer discussion, which will not only interact help them interact with fellow students, create that strong bonding of friendship, but it will also help teacher to gain a new perspective. So here previously during teacher centric, so there was time when you were just writing assignments after assignments, but these days that is not the scenario. You have to give students problem statements, you have to give them some topic where they can work upon on the area which is directly relevant to societal impact. So here they have huge range of choice in terms of project learn based learning. Maybe they can have capstone projects, or maybe they can come together, or or they can work as a team, or they can work as individual. So here if you see, the students by the time they complete their projects, even if it is for mini project, internship, or any capstone project, so they are able to evaluate their own progress. So I do remember many students, they come and tell me that this time I have done really good job. So even that remarks, such kind of remarks leaves me motivated that okay, some things are happening, some changes are happening, and it is really impacting the student. So if you see these days, teacher, when you talk about transformational teaching, he or she is not only an instructor, he is a facilitator. So it is just like he or she is acting as a catalyst. So they are initiating the reaction, but they are not participating it. They are just there to stand and observe. And if the student requires, the faculty or teacher can come and play his part, his or her part, and move aside. So here many things are happening where students are getting engaged in a very peer to peer interaction, where the learning is focused on them, where they have this right as well as freedom to retain that knowledge, to turn it into wisdom. Okay, so 15-20 years ago, it was just about receiving that information from one source and dumping it to another part. But these days, such things are not happening. So essentially, if you see, um, the three mantras which were given to us, skilling, reskilling and upskilling. So it is definitely true. So unless and until we as teachers, we as faculties don't update ourselves, don't transform ourselves, don't change our mindset, we cannot expect students to change and bring that revolution in today's society. So coming back to I guess very important part, I think even for me, I was motivated to go through Indian knowledge systems, foundational concept, to read more about it when I started interacting with Dr. Shrikant Kallurkar sir, as well as his long-term collaborator, Dr. Ulrich Berg. So many things are there. When we talk about in the ancient Indian knowledge, so I think if you see even the chat, which is part of this FDP, lot of things are being shared in terms of IKS. So if you see, as we all know that India is a originator of many things, zero being one of them. Even test tube baby. So many things are there. But if you see how such things or how that innovation is coming into picture. So if you see, many things are where the researchers or the innovators were proactively doing something which they felt, okay, this will work, not now, but in coming years. So that we can call it as inner awareness, self discovery at certain point in time where they felt, no, this will work, and for that I have to have that patience and perseverance. So self reflection, again purpose based teaching, having that mindful pedagogy is very important in today's modern education. So even if you are writing any one CO for a particular course, and you have to be very thoughtful if it is being mapped properly to a particular PO or PSO. So even when you think about particular lecture which you are going to give to a student, so you have to prepare a lot. So gone are the days when student used to come and teachers used to speak and they used to leave the class. So that is not happening, because these days students are curious, they know more than us, they are waiting for us to hear that right concept. So Gyanan, Vigyan and Jivan Darshan, again these are three foundational principles that combines the Indian knowledge system. So, if you see, there are still many schools in India which do have a Gurukul model um, of teaching, where the teachers are uh, teaching with purpose, where knowledge is being given with some relevance. Okay, so again, a holistic development of attitude versus what we try to compare in today's modern education as fragmented learning. So again, the role comes into picture of teacher as an instructor or teacher as a facilitator. But if you ask me, teacher throughout his life will be a mentor, quietly observing students' activity, and when required, to provide them that guidance and supervision, so that students do get that independence and freedom as well as individuality to move forward in his or her life. So again, for teachers, I think a lot of things are being said in terms of IKS, how it can be integrated in modern education. Now, this is again very vast concept. I think in today's 2 hour session, it is highly difficult to cover everything regarding IQs. But even for teachers, self-discipline, self-reflection, and purpose are very important. So, unless and until that is reflected in our day-to-day activities, we cannot expect students to come forward, approach us, trust us with their career. So, if you talk about transformational teaching, many things are happening. I think Bloom's taxonomy, I think everyone must be aware, because we use it, we have it in our mind all through our career, whether it is the level one, which is create, evaluate, analyze, apply, understand, and remember. But here, if you see, our focus throughout our semester or throughout the academic year is always to gain that top level, that is create. We always focus on how we can push or we can motivate students from that level one of remember to level 6, where he or she can create new designs, new maybe introduce new concepts, maybe take that leap and have some device or prototype that will help in overcoming some sort of societal concern. So again, if you see many activities are being implemented, at least I can talk about my college or institute. So it is under the umbrella of Marathwada Mitra Mandal, under which 16 institutes are there working as daughter institutes. So each one is driven with a different philosophy, but guided by one single mantra, that is benefit of masses. So if you see a lot of transformational things are happening in terms of experiential learning or introduction of industry based co-teachers, where we do have people from industries who are taking 1 or 2 units as part of the coursework. So even students have this opportunity that they can select a few of the topics and they can teach, where when the teacher just observes how he's teaching to his peers, his or hers, then there are a lot of encouragement for participation in competitive grants. So I do remember that last month we had this interaction with Dr. Shrikant Kallurkar, and we were trying to have this group of students who can work on Agnihotra topic, where we thought of implementing some novelties of ash and use it for developing some industrial emission filters, or maybe we can have some sort of humidifiers. So again, such kind of forward thinking projects are being implemented as part of modern education. So here if you see, we as a teacher, I think a lot of focus is always on reaching that level 6, where students can create something from whatever they have learned in previous years. So again, this kind of reflective learning experience will again engage in peer-to-peer interaction. So as a teacher, we should create many opportunities where students can interact with themselves, not only with students or their peers from same institute, but from other institutes as well, where they can have this case-based learning, maybe have some problem-based learning, and so on. So, coming back to transformational teaching, one of the basic model is that is being implemented everywhere is micro teaching model. So, I hope you must have heard about PDCA cycle, that is plan, do, check, and act. So, similarly, we have here a reflective learning model where you have given certain tasks, you reflect, you understand, you make some changes, you keep on improving that task, or come up with improved solution. So again, if you see reflective learning model, or many people do call it as experiential learning model, again they are very much part of your NEP, and because they do bring that multidisciplinary skill based flexible learning to the model, where students gain more, and they try to understand what is important to reach that level 6 of creating novel prototypes or innovations. So again here, many of you must have heard about Klopp's learning cycle also, where it is focused on 4 pillars, that is creating a concrete experience for student, reflective observation, then participation, and another thing is you have to conceptualize some ideas. So again, if you see over a period of time, teachers mindset is also shifting from that finishing syllabus to creating thinkers. I think 2 or 3 colleges which I had visited, so they were during the audit, they were not more focused whether that teacher has created 80% of syllabus or 90% of syllabus. So they were fine as long as the student outcome has reached to a newer values. So again, that mindset should shift from just finishing syllabus or delivering the content, but rather it should be focused on how student can gain upper hand in his career as a good human being. So he should be thinking from a societal point of view that there are few concerns in society, and I as an engineer should be able to provide some solution to overcome that impact. So if you see, a lot of comparison these days is again going on in terms of traditional classroom and smart classroom. So I don't know if you happen to have read this news that some European countries who had paid or invested billions of money in digitizing the classes are now going back to traditional classroom where they are encouraging students to read books, to read newspapers, to interact with each other instead of just going through the mobile. So a lot of paradigm shift is also taking place in terms of digitization, undigitization. But if you ask me and if you see the survey, so this digital market is here to grow. So if you see, it is nearly 4,000 billion economy. And if you see the graph presented before you, since 2024, it is going up, and it is expected to reach a very greater values in 2034 as well. So, in terms of this evaluation, whether we should be digitizing the education or not, yes, definitely digitization is expected, but how much or what till what extent, it is again up to us. So if you see, a lot of flexibility is being offered in terms of education institute which are having university status or empowered autonomy or so on. So a lot of things are coming into picture where there are a lot of do's and lot of don'ts in terms of that traditional teaching and transformational teachings. So have you people heard about phagital learning? Phagital learning. So it is, I think, a combination of two words, physical and digital. So student is able to grasp this concept while sitting in class. So we do have that smart classroom these days where you have implementation of many smart technologies in terms of creating that content where student is trying to get hold of advanced teaching, maybe newer technologies. So student sitting in particular classroom in a village, he is able to scan QR code and he is able to understand how neurosurgeon is able to remove that tumor using robotic surgery. So this kind of digital learning we are experiencing even at grassroots level. So if you see, there are eight C's of Phagital learning, right from connection, which includes connecting students to, or implementing that information or translating that knowledge through smart boards, e-learning platforms. So we do have lot of courses which are available online. Then captivation, which again includes newer grading systems, giving them merit of appreciation, giving them points, maybe some awards that will stay with them as a motivation, or maybe having those their photos tagged on boards saying best student or best um, participant and so on. Then in terms of context, you have lot of tools digital tools. For example, in workshop you can have lot of CNCs, SPM, that is special purpose machines. You can have lot of digital hardness testers and so on. Again, this culminates into content creation where you have a student who is unable to come to class or he's not interested. Maybe you can attract them through interactive teaching videos, have some classes for them to learn simulations and so on. Then again, there is communication. So long back there was this joke that teacher gives assignments to students and they are tagging the teachers on FB that this is my assignment. So I think even we are very near to that time when students will communicate us all those assignments in real time. They will provide us feedback. So gone are the days when students were afraid to give that honest feedback, but these days they are more open to that communication. And even for teachers, that feedback is very important. If you see, it helps you to learn, it helps you to engage them very properly. If you get that feedback, okay, what is stopping them from coming to classes and so on. Then again, even not only teachers but even students, they have good scope of collaborating among themselves with students from other institutes at national and international levels. Even teachers who are collaborating, they are also trying to engage their students to be part of that multidisciplinary teams and so on. So again, this improvement in the process, that is planning, checking, doing and acting. So it is a continuous process which is again resulting in consistent efforts in terms of good research outcomes, creating competent engineers, and so on. So, if you ask me in terms of engineering innovation framework, so many of you must have heard about this EPIC framework, which definitely integrates experiential or reflective learning. It creates pairs of students who can work together as a team, or they can work individually, where they can create some kind of prototypes or devices through active participation. Maybe they can present it at national competitions, win some award, pitch that idea to industry, ask for funding. Maybe this process will continue to grow. So again, if you see, we are at industry 5.0, whereas Japan has already started with industry 7.0. So a huge change is there happening at global scale, but I think even we are coming to that part. Then again, you have 4 C's in STEM education, that is critical thinking. You are analyzing, you are asking students to analyze, don't just read and come. So they are able to communicate. That open communication is taking place where they are collaborating, creating some new ideas. And if you see, a huge shift is taking place from OB to CB, where the learners, they are gaining some concrete skills. They are not just drawing information, they are drawing that knowledge and converting it into wisdom. So a lot of things are happening, and it is very evident that teachers' role. Again, I would like to stress on this part that teachers are not just instructors these days; they are becoming mentors in true sense. So, if you ask me how this IKS and smart technologies can be integrated, so IKS as a foundational concept is about ancient knowledge, cultural culture, traditional practices, and philosophy. So how we can club them together? So if you see, a lot of modern teaching includes abacus, where I think 2 days back I visited this class where students were being trained how to uh, do some tricky mathematics problems. using ancient mathematic principles. So again, three things are being evaluated over here: technology, social, cultural, and pedagogy. So here, it completely depends upon how the teacher reacts to the technology. If the teacher himself or herself is very apprehensive about that technology, it will be highly difficult for student to access that information. So we as a teacher, we need to update ourselves. We have to be at the front runner. We have to implement that thing so that even they are encouraged to implement those kind of technology. So many a times I have seen that teachers are encouraging students to use that AI, even to read that book. So I had this assignment given to students where I had asked them that you read this paper, which was based on Agnihotra ash and its property, and how it is being implemented in wastewater treatment or soil purification. So many of the students, they had used AI and they had come up with one page report. So it was indeed appreciative of them, at least they tried. So again, one basic thing is that if you see the Gurukul model, students were never being restricted or they were never stopped from learning new activity. So it is high time for us as teachers to show that freedom, or to give give this kind of freedom to our students also. So I think in many institutes they are accepting if students are writing some codes, or they are doing some projects, or writing reports using AI and ML. So again, there should be this holistic approach to modern education, which should be beyond the classroom. It should involve social skills in terms of maybe have some NSS activities where they adopt particular village, work with the village heads, and try to improve the environment in the village. Maybe they can try to teach some newer technologies, get advantage of that. Then again, in terms of assessment, so I think many of the institutes, they do have continuous assessment. I think it is mandatory these days. So regular improvement is very important, where which will in turn help student to come up with newer questions, improve their curiosity, and so on. So, coming back to case studies, as I had mentioned earlier, that in my lab, every semester I do recruit 4 students from second year, and they work with me for a period of 2 years. That is from second year till final year, and they try to gain that a different approach to academic teaching. So, since our main focus, my lab's main focus is on sensor development. So I'll be just presenting cases which are in sensor technology. So let me talk about one of my student who is currently a research associate at IIT Bombay. His name is Prasad Kulkarni. So he started his work on heterostructure development, where we develop different kinds of nanomaterial. And one of the material that really became successful while we were doing experimentation is tungsten trioxide and tin dioxide. So he was able to develop this material and use it for chlorine sensing. I think chlorine sensing, if you see, a lot of hazards are there due to chlorination and chlorine gas. So he was able to publish a research article in Q1 journal. He also have has this patent to his name, and he participated in conferences where he presented his work. And another thing is, by the end of his final year, he was able to secure a paid internship at IIT Bombay for a period of 6 years. After that, he was through class campus placement, he was selected in lesser also. So in this case also, if you see sensors or mechatronics, if you ask, mechatronics is combination of two engineering courses, that is mechanical engineering and electronics engineering. So students need to gain in-depth knowledge on sensors so that they can propose smart technologies which can be used in agricultural areas or food technology or even medical sciences. So another thing is, let me give you the concluding part of that student which I was talking earlier. So his name is Amit Kulkarni. So even with the second year, he managed to get very low CGPA, and then he started working for me. So one fine day, his father visited me, and he told me that I am Amit's father. And to be honest, I don't want to waste your time. So I just came here to inform you that let him do all the work in your lab. I'm not expecting anything from him. So I said, okay, fine, I'll take good care of him, don't worry. And then he started putting lot of efforts, lot. So I still remember we were developing this material for converting carbon dioxide into solar fuel, particularly hydrogen. And we were doing all those experiments in natural sunlight. So he used to conduct all those experiments on the terrace of the institute at 12, maybe 1 p.m., 3 p.m., like that, in very very difficult days. So by the end of the day, he used to get this all red and black, and it was very difficult to see him. So once or twice I mentioned to him that maybe you should stop doing this work. It is affecting you. And he was like, no, I will do it. I am interested and I will do it. So by the end of the semester, he started improving his grades because he felt, okay, I'm learning new things through this research activities, which I'm able to even implement in my regular academics. So his CGPA started improving. And one fine day, when I was working in my lab, and he came running to me. So I said, why, what happened? Did you get 9 CGPA? And he was like, no, it is better than that. I have won MITA's Global Link Research Fellowship, and I am going to go to Canada. I was shocked how this can happen. And I was like, okay, fine, this is really good. And by that time, he had published one paper in Q1 journal. He had a patent to his name. He had published two, three conference papers. He has presented his work. And with that kind of knowledge and skills, he decided to move further in his career, and he applied for this fellowship, and he actually secured that fellowship. So it was very motivating factor even for me that with such kind of work, even students are getting to know newer kind of areas which they wouldn't have known with their regular engineering studies. So they were able to remember those things, they were able to grasp that information, they were able to translate that knowledge into something newer and innovative. And with this, I think both Prasad and Amit, they created really good prototypes, really good sensors. And when we pitched this idea to industry, even they were happy. So many things were moving forward. So till here, anyone is having any question or any doubt, or do they want to share anything? There is this comment from Dr. Neeru Bala. I would like to read it. I choose teaching because I believe education has ability to shape minds, build confidence, and create meaningful change in the society. Teaching provides me with an opportunity to guide students, inspire curiosity, and support their journey from inner awareness to outer awareness, outer excellence. Sorry. Very true, Neeru ma'am. Very true. I think whatever the motivation that your answer has, and even you as a faculty have, I think it is very. It can be passed from one generation to another generation. It is really motivating. um, Paramjit ma'am is saying many like me became teacher by chance. I don't think so, ma'am. I think the career chose you. It was nothing by chance. Then there is another comment from Ginya Kakkar. Teaching gives me satisfaction when I feel my students are understanding what I am conveying. Very true. Even I think every teacher, every faculty can feel that satisfaction, that smile on students' face when they come with that pride that okay, I have done this and I was appreciated for that. It is really priceless. I mean, nothing can compare that. I mean, no amount of money can compare that satisfaction, that happiness. Um,
Madam, I wanted to say one thing because you
sure,
said
sir.
any comment. Uh, Actually, I would have talked to more than 50 teachers about
Okay.
projects in IKM. But you are the only one teacher who has come back to me and saying, sir, can you help my students to take up the projects in IKS? So here the teacher's mindset comes into picture. And that,
Yes.
in my opinion, is leading from within.
Yes,
Please.
very true.
Thank
I
you.
think Kallurkar sir, you as a teacher, I think you have been inspirational not only for me, but I think for everyone. I think the motivation and that excitement in your words, it is priceless. I mean, even when you say, okay, I'll be visiting the institution, let us discuss with students, and you won't believe more than me, students are so excited. Okay, we will be getting something new topics to learn today.
Great, great. Thank you very much.
Thank you, sir. So anyone would like to contribute anything in terms of your teaching experiences, or where you felt okay, students were having this kind of issues, and maybe with this changes there were a lot of improvements, something like that. So one thing here I would like to add that with this case studies, many of you must be wondering how this is related to IKS. So I would like to inform you that the two cases which I had mentioned over here, with Prasad's success and Amit's journey. So these were some with my previous institute, where we were just trying to come up with some good work so that the research gets funded from the funding agencies. And if you see, we are now currently focusing our shift from more of experiential learning, where whatever academic teachings are there, we do try that students they get that exposure in lab. So one of such ideas that we have been trying to develop is through IKS, in terms of employing homa therapies for wastewater treatment or soil purification. And it has been a personal enriching experience for me when I do study about such things, that our ancient Indian knowledge has been so ahead of its time, so ahead of its technology, that we don't need to justify it. We know it works. And it will advance that field not only in terms of sensor technology but even materials engineering. A lot of good applications can be used or we can initiate through IKS. So if no one has anything to contribute or to say, I'll just move forward. So further slides are regarding my own research work. So though my lab is focusing on energy generation, wastewater treatment, and sensor technology for medical application, but today I'll be keeping it a lot of brief so that faculties who are not from this area, even they can take advantage, get motivated. So if you see, India as a country is far lagging in terms of sensor labs. So in India, hardly 7 to 8 groups are there, dedicated 7 to 8 groups in IITs, NITs, and private institutes who are working on developing sensors. So if you see, if you go and have word with any of the industry near you, even they will tell you that most of the sensors are procured by them from other countries and it costs them a huge amount of money. So even if they are purchasing it from some other person, some other vendor in another country, the cost of that sensor increases a lot. So if you try to develop certain sensors in India, maybe they will be cost effective, affordable, and easily transferred even at grassroots level. So if you see Indian sensor market, it is estimated at the moment 15.64 billion, and it can go up to 77 billion by 2035. So you name a area and sensors are required, whether it is automobile, your car, your kitchen, your home or your industry or even your any medical hospital, everywhere sensors are required. So if you see the leading manufacturers of sensors, none of the company is from India, and this is where we should be focusing at the moment. So a lot of good names are there which are leaders like IFM, Baluf, Banner, and so on. So what is that is creating this huge gap in India's where India is not able to reach that global leadership in terms of sensor technology. So key points could be lack of R&D, good R&D in terms of enhancing that culture. Maybe we don't have sophisticated labs that can convert or that can collaborate with industries to have that good supply chain in terms of people who are not having those skills in sensor device fabrication, in terms of policy factors, and so on. So, if you see in my lab also, a lot of efforts are going on in connecting with industry so that industry and academia can work together. They can participate in sponsored projects along with industries. They can come up with IP creation, create some labs, some center of excellence, and so on. So in terms of sensors, if you see a lot of important sensors are there, but my topic of interest is CO2 sensors because if you see global climate change, greenhouse emission are huge contributing factors that are creating drastic climate change, ocean acidification, loss of life, and so on. So if you see CO2 gas, that is carbon dioxide, it is a strong asphyxiant. That is, if you inhale it, it will replace the oxygen in your lungs and it will take that place, creating nauseating effect or dizziness or even lot of other health hazards. So if you see even natural factors, they generate CO2, even anthropogenic factors, they generate CO2. But whatever natural sources are there, they are able to reduce it due to sink and source collaboration. But that is not happening with the human made factors. So whatever extra emissions are there, they are just turning up in the atmosphere. So what are the available methods? So many methods are there, that is spectroscopy monitoring, where you have infrared sensors which are commonly available as commercial sensors. You also have analytical monitorings, methodologies in terms of gas chromatography and so on. So in a way, if you see, both have certain advantages, certain disadvantages, and again depending upon the application you can choose the sensor. But here if you see, the sensors that are presented over here, they do lack that selectivity, which is very important. So selectivity is that if there are 10 to 15 gases, the sensor should accurately detect CO2 among them. That is very important. And if you see, both spectroscopic monitoring and analytical monitoring both doesn't contribute that much in terms of selectivity. So, in case of research which is going on, potentiometric sensors, that is sensors which are working on the principle of voltage. So sensor basically is, you have certain physical attribute that is being converted as electrical signal. So if you are getting that electrical signal in terms of voltage, it is called as potentiometric sensor. If it is given in terms of capacitance or resistance, it is called as chemical sensors. So if you see, potentiometric sensors, they can be widely used in petrochemical industries, mining industries, where the temperature is huge and there is lot of generation of CO2 gas, which again decreases productivity. So there was this common joke among software people that there is loss of productivity. So one of the manager said, just check if CO2 levels are high. So if you see CO2 levels, if they start replacing oxygen, it will surely decrease the productivity at the workplace. So in addition to that, these sensors are very selective, but they are very costly. They need a lot of investigation because many materials are involved. On the other hand, semiconductor based sensors, they are very easy to use, they are affordable, they can work even at low temperature. So a lot of differentiation is there when you talk about potentiometric and semiconductor. So there are three things here. In terms of potentiometric sensor, you have three electrodes. So during my doctoral studies, I had worked upon reference electrode. So it is very important because it maintains a fixed voltage, it avoids rapid deterioration of sensor, and it improves stability. So here if you see, the setup is there where you have two cylinders, one containing CO2 gas and the other containing air. You can mix this gas in certain concentration and pass it through sensor chamber, so that depending upon the concentration, the sensor will give you particular reading. So a lot of things are there in terms of data acquisition, reliable monitoring and data capture. So these are the sensors, very small shape. You can use them. So three things are over here. One is sensing electrode, solid electrolyte, and reference electrode. So basically, our main focus was on reference electrode, where we tried to do nanostructuring. And with this nanostructuring, we tried to improve the electrochemical stability. So if you see, this work was published in Journal of Materials Chemistry A. The huge factor that contributed to this sensor working was actually, if you see, four different materials are there, each having different shape and size. And this nanostructuring did help us to create that good quality material, which indirectly and directly contributed in its improving its stability. So if you see, we created octahedron. So after heating for 600 degree for 2 hours, there was phase transformation, and this phase transformation from cubic lithium titanate to FCC cubic lithium titanate did help us to achieve that stability of the sensor. Then we did some morphological evaluation using not transmission, scanning electron microscope, where we estimated its size and shape and confirmed its solid-solid phase transformation. So then we did other studies also on the other material which were part of this sensor to understand what kind of crystal structure and morphology it showed. So this is your an Ernest equation, which is a primary sensing mechanism for potentiometric sensor. So here if you see for particular gas concentration from 100 to 10,000 ppm, the sensor showed really good readings and it was working really good at 500 degrees Celsius. So we proposed this sensor to one of the industry in Australia, and they decided to uh, uh, take the IP forward in terms of technology transfer, and they did modify this sensor which was further modified in terms of packaging, and this sensor is actually deployed in one of the industry in Australia. So here we had this comparison in dry air humidity, because as a sensor it should work in all the condition, whether you are staying in Rajasthan, in Maharashtra, in Punjab, or even in Goa. So the sensor should work comfortably with good stability in whatever condition it is there. So we did that few studies in dry air and humid air, and the results were really good and comparable. The sensor was very quick. The It showed 5 seconds response time, and it was stable for nearly 45 days. So we didn't test beyond 45 days because 45 days is really good stability for us in sensor technology. So we created one nanostructured potentiometric sensor that showed 5 seconds response time for 500 degrees Celsius, good improvement and good stability. So we were having this discussion ki okay, we have this potentiometric sensor. We got a sensor which worked really good at high temperature, showed high sensitivity, showed long-term stability. So we were really motivated to go for sensor that can work at low temperature, should have simple fabrication and still have stability. Then we decided that we should start working on chemoresistive sensors. So in this case, most of the work was already established by Taguchi and Saima in 1962. Many sensors were commercialized, and then we decided, okay, so in terms of material engineering, we can do some hollow structures with good shape and size that will help us to increase sensitivity, selectivity, and stability. So if you see, in case of sensors, what makes a sensor perfect? So many things are there, right from its material, what kind of material you want to use, what kind of synthesis routes you want to use, how will be the packaging, at what temperature you want to use it so that deterioration can be avoided. So lot of things are there, lot of mix and match are there. If you see, it is a kind of a buffet. So if you want to make that really good pizza, you have to select the best toppings. And selection of these toppings will always vary from person to person. In the same way, if you're fabricating a sensor, it is always dependent on application. What kind of application you want to use it for, whether it is for food, whether it is for some agricultural activity, some medical sciences, or something like that. So Over a period of time, so since I have been working in sensor technology for last 15 years, so I have realized that for that perfect sensor, you need to have a synthesis route that will give you a material with higher defects, because higher defect and higher porosity will allow that gas interaction, which will create a really good environment so that the sensing of that particular gas is very effectively done. Again, you have to use certain PN junction, that is P type and N type semiconductor, make that heterojunction so that it will again enhance the sensitivity. You can also use some noble metals that will improve the catalytic role. Now, again, it's not like you have to use silver for every other gas. No, for every gas there will be different catalytic role, and each element will give or provide certain different. So you can use gold for maybe some gas, maybe for hydrogen you can use palladium or platinum and so on. So if you see the fabrication of this sensor, it is very simple. You have that cylindrical element on which the material is coated, through which a coil is passed, which will be acting as a heating element. And in presence of gas, it will start giving you that electrical signal based on the type of the gas. So one of the case study involved synthesizing zinc oxide and copper oxide. So here if you see slight change in the reaction medium. So reaction medium in our case was water and ethylene glycol. It will give you a different kind of morphology. So we had lot of options. We selected this marigold structure. Marigold structure, if you see, lot of thin sheets were there, a lot of porosity was there, which allowed gas interaction with the material, resulting in higher sensitivity and selectivity. So I have also kept this a beautiful lemon. So in research, I think there is this saying, not only in research but in actual life also, that when life gives you lemon, you have to make lemonade. So even that was really fine with us. We did try to make lemonade over here. So we did lot of characterization using XRD, where we studied phase transformation at different temperature, that is 300, 400 and 500. So if you see the morphology change right from thin sheets to perforated sheets, a huge difference was observed using scanning electron microscope. So, based on our requirement, we selected this interleaved assembly, which was consisting of knotted wires. So, knotted wires coming together to create this very beautiful structure. It was hollow, it was porous, and it really encouraged us in our experiments. Then we used decorated the structure with copper oxide. So we created this PN heterojunction that will enable us to achieve that good sensitivity required at lower temperature. So here also the response time was greater. That in initial studies we had response time of 5 seconds, but here it was 200 seconds. So still it is okay. 3 to 4 minutes, it's fine, because if you see the concentration of gas, it is 1%. So at different temperature, the sensor was tested, and we did found that 320 degree was really good temperature at which sensor readings were good and stable. Stability was not that good. For 40 days, we did try to test it, but initial readings were little up and down. But that didn't stop us. We decided to move forward with newer material. So in this case, instead of zinc oxide, we shifted our focus to tin dioxide. And tin dioxide did help us, because here though we tried to use copper oxide, but it created a different structure, that is CuO as well as Cu2O. So it naturally it was creating ppn heterostructure. So here, if you see, we did choose tin dioxide nanosphere. So each of the sphere was of 50 nanometers. We decorated it with copper oxides, that is CuO and Cu2O, and then further decorated it with silver. So silver really enhanced the sensitivity. And with this, we found that the crystal structure was really good, as the crystallite size was 4.6 nanometers. So it was very encouraging for us to achieve this crystallite size. Then we did lot of XPS studies and found that the copper oxide was present in +1 and +2 oxidation state. So naturally it was occurring. We didn't take any extra efforts for this. So again, if you see very good monodispersed spheres, that is monodispersed means uniformly shaped nanospheres, each having 50 nanometer size. So again, this data was really good, but if you see, the temperature was in previous case 320 degrees Celsius, and in current study it was 300 degrees Celsius. So not much of a difference. So, but we still went forward, and we did lot of dynamic studies, and we saw that the response time here improved a lot. We achieved that 5 seconds response, and even recovery time was 20 seconds. Yani sensor was able to react and detect the gas in 5 seconds, whereas it was able to come back to its original uh, case in 20 seconds. So this was really encouraging for us. Then we move forward. Instead of having that tin dioxide, we decided to shift to barium titanate. Barium titanate, if you see in terms of work function and other optical parameters, it was more matching with copper oxide, and we decided to use it. So creating the sheets on which copper oxide was deposited as spheres. So this also gave us good reading. And here we had this operating temperature of 120 degrees Celsius. So if you see, among zinc oxide, tin dioxide, and barium titanate, band gap was nearly same, but there was slight difference in work function. So work function of barium titanate was very low, that is 4 compared to others, and maybe that's why barium titanate did give us a good results. So when we compared these results and presented to industry, so even they were happy with whatever data we had provided them, and they encourage us to move forward. So in this way, we decided to digitize this sensor device in terms of having app where you can get the data in real times. So what we did, instead of having one single sensor of a particular material, we decided to use layers of these materials and form array. So these arrays, if you see, if you the major advantage of using this arrays, you can use it for 320 degrees Celsius also, you can use it for 120 degrees Celsius also. So a range of temperature is provided to you for detecting CO2 gas. And instead of using this cylindrical mounting, we changed our focus to planar mounting, and that also gave us good results. So if you see in when three of these materials were compared, barium titanate gave good results. Then second one was zinc oxide, and then third was tin dioxide. So over a period of time, tin dioxide there was deterioration observed. So here, if you see, we propose this kind of a sensor to industry where you can use it for range of temperature, that is from 100 degrees Celsius to 500 degrees Celsius, based on different materials. So based on our data set, we decided that we would want to used more different kinds of materials, maybe from the family of barium titanate, that is calcium titanate, and so on, so as to see how this family of materials will react towards CO2 gas. So again, if you see, the whole gist of this sensor study was to identify good material that will have compatibility with silver and copper oxide to form that PN heterostructure that will give us a good quality sensor, which can be used for varied application, right from low temperature to higher temperatures. Also, it should have that good stability, because if you see copper oxide, it is easily susceptible to carbonation. That is, CuO will react to CO2 to form copper carbonate, and it is very difficult to reverse that effect. So we do want to avoid that. So multiple studies are again in process, in going on in my lab. So if anyone is interested, maybe they can collaborate with us for such sensor driven studies. So, summing up my whole discussion, so I think throughout the session, we did try to understand how self discovery by teacher as well as student will shape that knowledge enhancement, and implementation of IKS, that is Indian Knowledge System, its foundational concept can provide those much required traditional values, purpose, and balance that will create teachers from facilitators, okay, to students who are creative thinkers. So again, smart technologies are must in terms of tools, softwares, to have that learning environment where student does feel that he is happy to gain that information, to accept that knowledge, and to translate that wisdom. So in true sense, if you see, for me, this FDP is where the teacher is the start point, where all those inner awareness is taking place, which will culminate in students who are giving out that outcomes, and that is how outer excellence will be measured in current era. So, my big things to take from this session would be, not only for you all, but for me also, very important self discovery, how the transition is taking place. In terms of teaching transformation, we as faculty have bigger role, because we should be skilling, upskilling, rescaling ourselves on every minute basis, so that whatever knowledge we have, whatever wisdom we can give to student, it will put him or her in that one step ahead. So definitely encouragement of smart technology, its integration, very important in terms of project based learning, projects, internship, industry academia collaboration, capstone projects, industry co-teaching, so on. So if you see, though we are implementing student-centric models, micro-teaching models, it should reflect in our teaching as well as in their learning. So basically, what comes from us should be experiential and reflective, and what they should feel is inspired. So again, teachers are not only teachers, they are mentors, they are nation builders. They are there to have that future a country is always thinking. So another thing is, I think this I keep on telling to my students every day, that I don't expect you all to do bigger things. Just do small things on regular basis. Do it for 21 days, because if you want to improve or implement any good habit, you have to do it for 21 days. So small changes, they start from us, which will we will be seeing in our student in terms of big research outcomes, innovations. Okay, so again, as a teacher, I think many of us are implementing that. We are not just focused these days on finishing the syllabus, but we do want to see that transformation and transition in our students. So with this, I would like to end my session. So thank you very much for being there. I would like to thank the chief patrons, organizers, conveners at Khalsa College of Engineering and Technology, Khalsa University. So it's really good that such topics for FDP are coming up. These are not your regular topics. These are required topics. How inner awareness is important, IKS principles are there, and how that outer excellence will be measured and valued in coming days. So it is a very important topic. And when I was sharing all these talks or details on my LinkedIn network. So many people were very curious that can I join this session? It looks very engaging, very insightful. So I would like to congratulate the organizing committee for coming up with this topic. And lastly, I would like to thank Kallurkar sir, who has been inspiration from day one. I think his knowledge and his experience speaks volume of great things he continues to do on daily basis. So with this, I would like to end my session. Thank you so much.
Thank you, ma'am. Dr. Atul here. Thank you very much for your such an enlightening and inspiring session. On behalf of Khalsa College of Engineering and Technology, Amritsar, we extend our heartfelt gratitude to you for sparing your valuable time and sharing your immense knowledge and experiences with us, ma'am. Thank you so much, ma'am.
Thank you.
So, can
So
we end this session now, ma'am? Or
sure,
if
sir.
any participant having any doubt, or if you want to interact with the ma'am, you can discuss. If you have any question, any queries, you can ask. Ma'am is open for the all the queries.
So I would like to take this opportunity that if you are interested in working in the areas of sensor technology or nanomaterials, please feel free to connect with me. My students are there. We are always ready to collaborate. We can start with small experiments, small ideas. We can work upon problem statement. So we are always open for collaboration. Thank you so much.
Yes, ma'am. Thank you much. Thank you very much, ma'am. Thank you so much. So we can end the chat now and end the session as well. Thank you,
Okay.
ma'am.
Thank you.
Good evening, ma'am.